Why does net entropy, remember entropy is like disorder, right? When a hot object comes to equilibrium with a cold. So let's just draw a simple picture here. I'm going to show I'm going to answer this two ways, right? Let's answer it conceptually, right? So here's hot, here's cold, okay? This is more information. If you ask me where the fast-moving molecules are, I would point you to here. And if you wanted a slow-moving molecule, I'd point you to here. So I have more information. I've got hot, I've got cold. They're in two neat little compartments, right? And later, we just sort of have lukewarm. Where are the cold particles? I don't know. They're in there somewhere. They're all mixed up, right? This is all mixed up. It's all mixed up, right? So therefore, we've increased the disorder. We've mixed the hot and the cold. It's disorderly. Okay, now the formula for this strange formula, right? The change in entropy is the change in the heat that flows divided by the temperature, right? Okay, when heat flows from hot to cold, okay, we've got a change in entropy for the cold is going to be the heat. Let's imagine that some amount of heat flows. It's Q has to flow, right? It's going to be positive. The heat flow to this guy is positive, right? And it's going to be divided by the cold temperature, roughly, kind of an average temperature, but it's going to be a cooler temperature. The change in entropy for this side will be negative, whatever that is, because the heat will flow out of this side, but it'll be divided by the hot temperature, okay? On average, TH is going to be bigger than the cold temperature until the very end, then they'll be the same, right? But on the average, during that whole process, the high temperature, since it is the high temperature, will be higher than the cold temperature, right? So if you look at this, there's actually a negative change in entropy and a positive change. The positive is larger because the denominator is smaller. Yeah? So this, if you add these guys up, that's going to be bigger than 0, okay? Because this denominator is smaller, this one's bigger. The decrease in entropy is smaller than the increase because of math.